This video goes with assignment CM 2.1 on page 25, problems A and B. We did problem A in class, and so I'm going to give an example of how to do problem B. So I'm looking at problem B, and it looks like there's a company called First State that's bidding on painting a bridge. So it has some records of some other bridges that they have painted, gives the length and the cost. And what I'm going to cover is just plotting the data, drawing the line of best fit, and then seeing if we can come up with an equation. So the students have to not only do those two things, parts 1 and 2, but they also have to answer 3 and 4 for part B. So I've taken that data out of the table and I've transferred it over to my graph. So when you look here, I have in the data table, I have the length of the bridges and of course the cost. And so I'm going to label my XY axis. Remember, my x-axis is going to have the length, and my y-axis is going to have the cost. And I need to plot that data, so before I plot the data, I better look at what I should scale it. And see, I got to get up to 500. So on the x-axis, I'm going to start at 0. And I think if I go every 4 boxes, I can do 1, 2, 3, 4, make that 100. 1, 2, 3, 4, 200, 300, 400, and 500. That should work. So I'm going to label those. And then on the y-axis, it looks like I need to get up to $140,000. So how I'm going to label that, I think I'm going to start at 0. And let's see if this will work. Let's see, 20,000, 40,000, 60,000, 80,000, 100, 120,000, 140,000. That should work. So I'm going to label those numbers. Let's see, 20, 40, 60, 80, 100, 120, and 140. And because I didn't put all the thousands there, I should probably say that my cost is in the thousands. And it's going to be doing some other stuff that I'm going to label that my cost is in thousands. Okay, so let me readjust this. Okay. Probably need to scroll down this a little bit. I can see my 140. Okay, I'm going to go ahead and plot the data. So let's see. If the length is 150, my cost was 50,000. So I find 150 on the x. I find 50,000 on the y, and there's our data point. If the bridge is 300 feet long, it costs 80,000. So 380,000 right here. And my last data point would be if the bridge was 500 feet. The cost would be 140,000. So when I plot that point, it goes up there. Okay, so I plotted my data. My next step is to find a line of best fit. So I'm going to do a line of best fit here. I'm going to need to adjust this. So let's see. I'm thinking that that's maybe needs to be adjusted a little bit. But I have, first I'm going to shorten this up just a tad. And it looks like I have a data point above. I have one below. And this one here, if I move it down a little bit, that's a pretty good average of my data. A couple points above, one below. I think I'm going to try that right there. Okay, that looks pretty good. All right, so I plotted the data. I've done a line of best fit. Now I'm ready to start to write my line equation. Well, remember, my line equation is in the form of y equals mx plus b. And there's two things that we're going to substitute, the slope and the y-intercept. So I'm going to put m equals, that's my slope, and b equals, that's my y-intercept. And as I look at it, I think of those two, the easiest one to find would have to be the y-intercept. So when I look at the y-intercept, I'm just going to put a green dot where I think that is. It touches right about there. And if I look at the way I scaled this, I have 0, 10,000, 20,000. It looks like it's about 5,000. So I'm going to put 5,000 right there for my y-intercept. And now I need to do my slope. And when I do slope, I could care less about the data points anymore. So I'm going to erase those data points. I really don't even need them. In fact, I think I'll keep them up there so that you can see them. But I'm not basing it off of the data points. So I'm trying to find perfect intersection lines of the line of best fit in the grid. And so as I go along, I see, well, there's a perfect intersection point, pretty close. That looks like a pretty good one there. That doesn't look too bad there. Let's see, that's not too bad there. I could probably keep going and find some more. That's pretty close there. That's not too bad there. I'm going to connect some of those to find my slope. So let's see, I think I'm going to pick these two right here to make my right triangle. And now here's the problem. When students find slope, they think that each one of those boxes counts as one unit. And so they usually do 1, 2, 3, 4, 5, 6. They say that that's 6 units long, and the rise is 1, 2, 3, 4 units long. But that's not correct, because remember, each one of these boxes doesn't really stand for 1 unit. I have to go down here and say, well, how does it scale? 25, 50, 75, 100, 125, 150, 175, 200. Each box counts for 25. So I've got to get rid of that 6 and count by 25s. 25, 50, 75, 100, 125, 150. I think my run is 150. Now I got to scale, or see what my scale is for my y-axis, and it looks like it's going to be 10,000, 20,000, 30,000, 40,000, 50,000, 60,000. Looks like each one's going to be 10,000. So 10,000, 20,000, 30,000, 40,000. I've got to add some zeros here. And now my slope should be rise over run, so 40,000. All of that over 150. I should be able to take off a 0 off of each one. And I'll let the students go ahead and reduce that, which would be 4,000 divided by 15 to get their slope. And from that point, they should be able to generate their line equation.